to talk about surface control system. This surface control system consists of, or here POP control system for surface installation, normally supply hydraulic fluid in a closed loop circuit as actuating medium. So first thing is the reservoir tank. Here is the storage tank or reservoir tank, okay, filled with hydraulic fluid, okay, has capacity of 2 times of the hydraulic fluid required to make the functions, okay, or 2 times to fill the accumulator bottles. So here, storage tank or reservoir tank is used for supplying ample fluid to the pumping unit. Now here, the pumping unit starts to take fluids via suction lines through the storage tank or reservoir tank. We have 2 types of the pump. We have electric pump and we have pneumatic pump. Okay, so we have electric and pneumatic. Both of them, electric and pneumatic, is used for pressurizing the control fluid till reaching to pressure of 3000 psi, okay, on the bottles. Accumulator bottles now started to store the pressurized control fluid, okay, so its pressure now is 3000 psi. Now you have a hydraulic control manifold regulator and the annular regulator to can adjust the 3000 psi into the required pressure. If it is manifold, so adjust it to 1500. If it is annular, so to adjust it from 600 to 1500 psi. Now we have here remote control panel. The remote control panel is a panel allow you to make the function from a remote location, okay, not from the unit. Here is a simple schematic for the CAMI unit. First thing, starting by here, we having air compressor. Now the air starts to come here to this point till passing to the air lubricator. Air lubricator, as if the air is dry, can cause some erosion to the equipment. So now this is air lubricator, okay? Then once air comes to the pneumatic pump, start running it. And here for the electric pump, this one electric and this one is pneumatic. So electric pump has electric power supply, okay, auto electric starter to run it. And here for the pneumatic, it runs with the air pressure. Here is the reservoir tank. So both pumps start to take fluid from the reservoir tank through suction lines and start to raise its pressure to 3000, then store it here in the bottle. Okay, the electric pump is designed to run if the pressure of the fluid gets below 90%, 90% of the full accumulator pressure. This means when the pressure reaches 2700 psi, the electric pump starts to run to raise the pressure to 3000 again. And if there is a problem with the electric pump, so once the pressure decreased to 85%, so it's about 2550. So now the pneumatic pump started to run to raise the pressure to 3000 psi. So we have 2 barriers. First one at 90% and below, electric start to run. Once electric not running, you're gonna find here pneumatic start to run. So we have 2 pumps acting together in place to reach the pressure to 3000 psi and store it here in the bottles. Okay. Once we have 3000 psi here, so we can make the function, take the fluid or the pressure from the accumulator bottles to the manifold line. So here we having our manifold line, this one, okay? So the manifold line has now 1500 psi through the manifold regulator. And here we having annular regulator to adjust the pressures. Okay, so this one is the manifold line. And these valves, 3 position 4-way valve for the different types of rams, okay, and HCRs, different types of rams, okay. So here we having on the manifold line 1500 psi, so can make the function from the manifold pressure. And in case we want to make the function of shear ram, so here we having bypass valve take the pressure through this valve, okay, activated. So now we having 3000 psi on the manifold line, so we can cut the pipe if we want. All of these regulators, okay, and the gauges, we having here manifold gauge, accumulator gauge, and annular gauge. All of these is lined with pneumatic transmitters and transducers. These transducers is connected with here with air junction box, and the air junction box is lined up to the remote control panel. So you can make the function from a remote area. If you look here, we having here panel selector valve. If the panel selector valve is to the unit, so you can only open and close from the unit from here. But if it is to the panel, so you can do the function from both places, from the panel and from the unit. Okay. Now let's go ahead. Here is the reservoir tank, pneumatic 1, pneumatic 2, electric pump. Take fluid from reservoir tank, start to raise its pressure to here 3000 psi. Now we have annular regulator and manifold regulator taking the pressure to open and close lines to the annular and the set of rams. Here is the BOP control unit with the gauges, accumulator gauge, manifold gauge, and annular gauge. Here is the bottles, okay, and here is the hydraulic lines, close and open lines, BOP stack. Here is the manifold regulator to adjust the pressure. Here is the 3-position 4-way valve, open, close, and neutral position. Here is the 3-position 4-way for the annular, open, close, and neutral. And these 2 lines for open and close. Here is the gauges. This one is the accumulator. Here is the manifold, and this one is the annular. If you look here to the shear ram, you're gonna find that covered. Okay, so not anyone by mistake can open or close. Here is the electric pump, the pneumatic pump, and here to reach to the accumulator calculation. Once the bottles come to the surface, it will have a pre-charge pressure 1000 psi. It will pre-charge it with nitrogen. Why nitrogen? Because the nitrogen is an inert gas. Okay. Then once running the 2 pumps, reaching the full accumulator pressure 3000 psi. Okay. Once reaching 3000 psi, we have to conduct a test called drawdown test. Drawdown test is to close annular, close minimum 4 rams. Okay, then open HCR. Once you do all of these functions, so the remaining pressure should be 1200 psi or larger. This one is called minimum operating pressure. Okay, minimum operating pressure. If the pressure after making the drawdown test is below 1200, we need to await 15 minutes. If it's back again to 1200, it's okay. If not, wait another 15. If not, this one is not accepted test to check for the problem. Here is the remote. Yeah.
Sorry, for the drawdown test?
Yes.
Drawdown test, I know
yes.
that's for the BOP stack configuration. So to open all the valve close and close all the valve open and do it 2 times, open and close.
Open and close, you simulate for closing 4 rams, right?
No, yeah, I mean for the annular, we have to close and open. For the ram, close and open. For the SCA, we have to open and close again. And
so you mean
all this function?
Yeah.
That's what I get last.
So you need to close annular, open annular, then close ram, open ram.
Yeah.
No, close annular only, close minimum 4 rams, and open HCR. You can simulate for shear ram, for example, if not existed, if shear ram is existed, by open the ram. So here, if you have 3 rams and the shear, instead of closing 4 rams, you can open another ram. So now you close 3 rams, open another one. So you simulate as you closing 4 rams. Now you close annular, close minimum 4 rams, open HCR, and the remaining pressure should be 1200. If you close, open 4 rams, then open HCR, no, you can't be able to make all of these functions. Okay, so the drawdown test is to close annular, close minimum 4 rams, and if you have shear ram, you can simulate, you close it by opening another ram. Okay, so now you close annular, close minimum 4 rams, and open HCR. Then the remaining pressure should be 1200 psi. If not, you need to await 15 by 15. Is the pressure back again? So it's okay, accepted test. If not, back again to this value. So you need to check the pressure. It is not accepted test. Now here for the remote control panel. Remote control panel is just a descriptive figure for the BOP. You have the master valve, push valve, okay, and open and close for all rams and HCR. Also, you have a digital counter for accumulator pressure, manifold pressure, annular pressure, and rig air pressure. Okay, to use this remote control panel, it's called two-handed operation. You need first to push the master valve, then open or close the function you want. Once you push the master valve, you activate the air and the all panel. Okay, so you can do the function once you push the master valve. Okay, let's mention, for example, here, if we need to close the annular. So we have open and close. Okay, let's say annular pressure regulated 1000, and here we having the accumulator pressure is 3000. So once we need to close the annular pressure, push the master valve, then press close. Okay, once you press close, light should be changed from green into red. Okay, once the color is changed, this gives you indication that the three position 4-way valve is working properly. Okay, so once the light is changed, this is indication that the 3-position 4-way valve is working properly. So how to confirm the function is already done closed? Okay, by looking to the pressure. If the pressure 1000 dropped and 3000 dropped, then back again to its nominal value. So now the function has done correctly. Okay, but if you found that the press push valve, okay, then the color didn't change, okay, but you found pressure dropped and back again, now also the function is done. If you look that after pushing the master valve, then press close and the color is changed into red, okay, changed into red, but once you look to the pressure, stay constant, okay, so now there is a plug into the closed line. Okay, so if you look to, if you need to close, push the master valve, another case, the color didn't change and the pressure stay stable, didn't change. So now the 3-position 4-way valve is stuck in place. We're gonna see now. Here is the remote panel to the BOP. Rig air, once pressing master valve, activate air pressure and the remote panel, so you can send signals to the BOP. Here, when the POP ram in closed position, closed line has 1500. If it is in open position, so open line has 1500. When the 4-way valve shifts, the micro switch will activate the light to illuminate. So once light illuminates, this gives you indication that the 3-position 4-way valve is working properly. Okay, but if you found the color didn't change and the pressure is dropped, then back again. So this is a problem with the light bulb. Okay, light bulb itself. Here, when light illuminates, it tells us the oil on its way or hydraulic fluid on its way to the POP function, but not confirmation. The confirmation when you look to the pressure and found pressure drop, then pressure build up again. Here is the junction box connected to the junction box of the unit, okay, through airline transmitter transducer, so you can make the function from a remote area. Here is the 3-position 4-way valve. open, close, and lock position. So once you are in open position, okay, open position, so all pressure, okay, in the system will go to the opening chamber, okay. So the close the volume here back again to the drain, okay. But if you move it to the closed line like this one, so all pressure in the system will go here in the green line, so you can close, and the volume in the red one will back again to the drain like this, okay. So three position, open, block, and close. Four way we have drain, pressure, open, and close. Could you check this one, please, guys?
Option D.
Yes, D. Okay, good. What about this one?
Option C.
Yes. Three position four-way valve stuck in its position. Okay. Why? Because light didn't change and pressure static. If light didn't change and the pressure changed, so now the problem was with the bulb. Okay. If the light changed and the pressure remains static, so now there is blockage in the line itself. Okay, so the three position is work. Okay, good. Now to talk here, choke manifold, upstream and downstream, some of arrangements of the valves to control the fluid passage. Here is the choke. The choke function is to create back pressure during circulating Gauda kick. When the influx comes from here, okay, you need to open and close the choke to add more choking if you want to increase the bottom hole pressure, or open the choke somehow to decrease the casing and bottom hole pressure, so you can control the circulation of the influx. Here, could you please check this one, guys? What's the main function of the choke?
Option D.
Hold the back pressure, yes, while circulating. Okay, what about this one?
Option A.
Yes, this is the problem lead to bigger influx when you calling the tool pusher before shutting the wheel. Okay, here is the remote choke, guys. Remote choke has here two gauges, drill pipe gauge, casing pressure gauge, and choke arm to open and close. Here is the speed regulator, okay, and this one is the choke position gauge. So you can use during killing the well through the remote choke panel. Here is the mud gas separator. Once the influx comes from the choke line, till passing the remote choke, now in its way to enter the mud gas separator. Mud gas separator has some baffles like what you see here. So these baffles, when the influx hits, the gas starts to liberate from the influx to be out from the mud gas separator. We having here the good mud back again to the U-tube. Okay, this U-tube provide the operating pressure required for the mud gas separator. So if let's have a clear one. Yeah. So here this U-tube has a good mud. So this good mud provide hydrostatic pressure, and depending on this hydrostatic pressure, we can determine our operating pressure. Okay. So here the gas provide a pressure. Okay. This pressure of the gas should not P equal or greater the hydrostatic pressure by any way, not to allow the gas overloading the mud gas separator and enter to the U-tube, then to the shaker area. Okay, so here hydrostatic pressure, for example, if we have hydrostatic pressure here 10 psi, okay, so this is our maximum. So the operating pressure, this one, shouldn't be reached to the 10 psi or larger. Once you found the operating pressure starts to increase, you need to take an action. For example, slow the rate, okay? If you use 40 SPM, use 30 instead. If the problem is still existed, you can shut in the well and start pump from here, from the hot mud inlet, start to pump new mud inside the U-tube to keep your pressure higher, okay, to prevent the gas from entering to the shaker area, and with any simple agitation can cause firing or explosion. For the mud gas separator, the back pressure from here can depend on the vent line ID and the vent line height, and the maximum pressure of the mud gas separator depending on the depth tube height, this one, depth tube height, and the mud seal, the hydrostatic pressure, depth tube height, and the mud seal level. Sometimes in the exam asking about this one, okay, asking about the maximum pressure of the mud gas separator depending on what? Depending
also the vent line length, no? Depend of the pressure.
Back pressure, vent line,
Yeah.
vent line ID, and vent line length. But maximum pressure of the mud gas separator, the working pressure depending on here on the depth tube height or U-tube, the mud seal. So the working pressure is depending on this one. Once the gas pressure started to increase, okay, so you didn't allow to reach the mud seal, okay, or the hydrostatic pressure. This is the maximum operating pressure for the mud gas separator. So all the time you need to keep the gas pressure less than this value, not to overcome or overload the mud gas separator and allow gas to reach to the ship. So here the pressure buildup depending on the vent line characteristic, vent line ID, vent line height, and the maximum pressure depending on the U-tube height and the mud seal level. Okay, so could you check this one? Why can a pressure buildup in the mud gas separator be dangerous?
Option B.
Yes, may force gas to enter the shaker area. Now to talk about the vacuum degasser. Vacuum degasser is used downward the mud gas separator. Okay, so it is used to remove gas after the mud has been circulated across the shaker. Okay, so it can be used in drilling operation downstream the shaker. Also can be used in circulating out a keg. So it has two options: to use while drilling operation, to use while circulating a keg. So mud gas separator only be used while circulating out a keg. So mud gas separator can't be used instead of a vacuum degasser, or vacuum degasser can be used instead of mud gas separator. Everyone has its specific job, and mud gas and the vacuum degasser has a volume limitation. Okay, so can be used instead of the mud gas separator. So here is a question: what is the most common use of vacuum degasser? Could you check?
Option D.
D.
D, yes, it's used to remove gas after mud has been circulated across the ship. Okay, now to talk about step-in valves or safety valves. Okay, so here step-in valves, once we are in tripping operation, trip out or trip in from the well, we have full opening safety valve on the rig floor, we have IPOP on the rig floor, both of them in open position. So once we are tripping out from the well like this, we have full opening safety valve in open position. If we have a flow, so we need to step in the full opening safety valve in open, then close it by the wrench. So now we're having full opening safety valve in a closed position. Then run the IPOP above it, okay? IPOP in open position now. Once you remove this lock screw, so now IPOP in closed position. So now we have an IPOP in closed position, full opening safety valve in closed position, okay? And if you need to strip back, you need to back again open the full opening safety valve, and you can strip back to the bottom. For full opening safety valve, it's easier to stab than the IPOP. Also, in case of IPOP, now we run the IPOP in a closed position. So no communication between the fluids and the gauge. So in case you wanted to get the shot and drill pipe pressure, you need to pump like the float valve pump to open the IPOP so you can record the pressure, okay? You are not able to run the wire lines through the IPOP inside blowout prevent. So this one, when two drill string safety valves have to be tested each time POP is tested. So we need to test the drilling safety valves, the IPOP, and the full opening safety valves. So could you check this one, guys, while tripping? Soft shot in. D, this one. You need D?
No, sorry.
Okay. Let me make it easy for you. While tripping, first thing to stab for opening safety valve, stab for opening safety valve. So you need to choose between B and C. Stab for opening safety valve, then close the safety valve. So it will be okay.
Let's see.
Then, yeah. So soft satin, you need to open HCR first, then close POP. Okay. Second one, while tripping, same thing. While tripping, use hard shutting. While tripping, stab full opening safety valve, stab full opening safety valve. After stabbing, you need to close. So this one, close safety valve, hard shutting, close POP, open HCR, and record the pressure. Okay. Now here, the float valve. The float valve is used as the drill string to prevent any backflow during circulation. If it is existed in the drill pipe, so you will not be able to record shot and drill pipe pressure. So you need to start pump slowly, for example, 5 SPM till communication happen and the casing pressure start to increase. Once casing pressure starts to increase, you can record shot and drill pipe pressure minus any extra pressure on the casing pressure gauge. Okay, so could you check this one? What statement is true if a non-return valve is stabbed into the string? Non-return valve here is the IPOP. Could you check?
Answer D.
D, yes, has to be pumped to open and read shot and drill pipe pressure. Okay, now to talk about last thing is the connection, API wellhead connection. We having here the flange type is the most common one for connection, clamp hub and studded. For API flanges, we have two types, type name 6B and another one 6BX. For 6B, we have two ring gaskets to be used, R and RX. For 6BX, we have only PX ring gasket to be used, okay? For 6BX, we use that for high pressure rating wells and for gas wells from 5 to 20,000 PSI. And here for 6B, only for low pressure rating from 2,000 to 5,000. Let's look here to this slide for 6B flange. You're gonna always all the time see standoff between the two flanges. So we need to retighten after the test. But here for 6BX, no standoff. So it's gonna be used for high pressure wells. Ring gaskets to be used once a time, okay? Not to be used more than once, okay? Even by visual inspection, it's a good status. So you need to change it because once you are applying pressure, it takes the shape of the placed it. Okay, so you need to use it once. But before using the ring gaskets, you need to clean its place, then dry it. Here there is a hole in the ring gaskets. Okay, only for self-energized gaskets RX and BX. So the ring gasket can take the shape of the flange. Okay, flange groove. So no leaking can happen across the ring gaskets. Could you check this one, guys? Which of the following statement about gaskets is correct?
Option A.
Yes, BX and RX called pressure energized seal. Yes. What about this one?
Sorry, BX and RX or only BX?
PX and RX called pressure energized seal.
Because in the previous slide is only BX. So.
RX and all PX, some RX and PX.
You see in the BX there is one hole here, but in the RX there is no hole. I don't know.
No.
Oh.
We have R, RX and PX. So X and X is self-energized, but R no. Okay. So we have three types of gaskets here: R, RX, PX. PX, RX, the one ends with X is self-energized. All PX is self-energized. Some of RX are self-energized. Okay. So the question comes as you see, which, so the answer will be type PX. But some of RX also can be used as a self-energized or pressure energized. Okay, so what about this one?
Option B.
B, yes, 5,000. So the maximum will be the rated according to the 5,000. Okay, guys. So now I think we finished the equipment part. So any questions related to this point?
Yeah, if we can come back to mud gas separator.
Yes. Mud gas separator. Yeah.
No, the other. Go to other slide.
Yes.
No, the other, forward.
This one or previous?
Other one. Forward. Yeah, here the pressure build up.
Yeah, pressure built up on the mud gas separator, depending on the vent line ID. This one, okay. Vent line ID and vent line height. If the vent line is small, so you can apply back pressure.
Should be vent line length, not height, because the length will make friction.
Yeah, length or height. He means this part, this area here, vent line height. Again, sorry.
No, yeah. Because the height is making maybe the gas gradient or something.
No. Here he mentioned for I got your point. So if the length may be usually higher than or larger than height. So the length, if it is increased, it can cause yes,
more friction.
Right. Yes, you're right. But vent line height actually makes sense. So vent line height, if it's large, so for example, if we have two mud gas separator with one vent line ends here, another one ends here, so it depends on the height. Also, it depends on the length. So if you mention for the two parts, you're gonna select length. If height only, so it's accepted only, no problem. Okay. Okay. What else? Okay, guys. So let's start to open our exercise book. Have simple questions to solve. Okay. Let me finish this one.